Hello, everyone, and thank you for your time. So, to start off, I'd like you guys to take a moment to think about how your body reacts under social pressure. We might get nervous, we get sweaty palms, our heart starts pounding, right? Well, how much do scientists really know about how what is going on up here exactly affects our body and impacts how we adjust in social environments? One particular population of interest has been a group of people that we know exhibit atypical nervous system responses, specifically individuals who exhibit psychopathic traits. And let me tell you, discerning how and when mental state impacts the nervous system is no walk in the park. So let's review a little bit about the autonomic nervous system. It's a system of our body that works behind the scenes. There's two branches that constantly balance each other. The sympathetic nervous system is our fight or flight response. So when you're approached by anything that your body deems as a threat, your heart rate goes up, your breathing speeds up, and you start to sweat more. The parasympathetic nervous system is when you want to rest and digest. So if the sympathetic nervous system is needed, we expect the parasympathetic to take a step back and decrease. But once the threat is out of the way, we expect sympathetic nervous system activity to go down, and parasympathetic can go up and keep us at our baseline. Now, shifting a little bit, if we imagine a spectrum, we'll have internalizing traits on one side, and this includes things like anxiety and depression, and externalizing traits on the other, and this includes things like conduct disorder and callous unemotional traits. Callous unemotional traits, or CU traits, are a set of characteristics that encompass low levels of guilt, empathy, fear, and prosociality. See, these traits are also a risk for antisocial behavior and psychopathy. So, what exactly is the link between CU traits and autonomic nervous system functioning? More specifically, the central question here was, how do sympathetic and parasympathetic systems function in CU individuals during periods of social stress? Well, given lower levels of fear and empathy, we expect them to have lower levels of sympathetic nervous system activity, right? They're not feeling the fear, so their sympathetic nervous system isn't seeing a threat, so it's not activating to get them ready to fight. But recent studies have actually shown that CU individuals are expected or have seen higher levels of sympathetic nervous system activity in specific contexts. So, a recent study showed that in CU individuals that were of undergraduate age during a virtual reality horror video, scientists actually saw co-inhibition. So, sympathetic and parasympathetic activity were both going down. You weren't seeing this normal counterbalance that we usually do. In another more recent study, virtual reality roller coaster fear conditions showed that children aged 12 to 14 who had CU traits had co-activation. So their sympathetic and parasympathetic activity were both going up. Again, we weren't seeing that counterbalance. So, due to suggestions from the literature and the pertinence of creating a relevant fear context, we decided to look at a social context. We looked at participants, 50 students aged 18 to 22 years old. CU trait levels were measured using questionnaires, and participants came into our lab and did the Trier social stress test while we recorded their physiological responses. The Trier social stress test is a task designed to induce social stress. We conducted a novel variation of it. So there are 5 tasks. First, they had to prepare a speech for 4 minutes about what makes a family and why. Next, they had 5 minutes to deliver that speech. Then we moved on to the scenarios portion of the task. In this section, we asked the individual to imagine they're walking through a park and they see a child hit another child with a stick, and then they see the mother loudly reprimanding that child, and then they see the mother hit the child. So the participant is asked questions like, do you think this was appropriate, and how did this make you feel? The next scenario is called the coffee task. And in this task, the individual is asked to imagine that they are waiting to meet with a professor when their peer bumps into them and spills coffee on their shirt and leaves without apologizing. They're asked questions like, how likely is it that your classmate did this on purpose? And finally, we had the math task, in which participants were asked to count down from 1022 by 13s. So while they were doing all of these tasks, we were recording changes in their physiology. As we know, your fight or flight sympathetic nervous system kicks in and you sweat more. When you sweat more, your skin ducts fill up with water, and water conducts electricity. So scientists have used this phenomenon to assess fear responses through electrodermal activity, or EDA, in which a detection of sweat production above a certain threshold indicates a skin conductance response. Now, it's not very adaptive or healthy for your body to constantly keep you in this high level of stress, and this is where the parasympathetic nervous system comes in. Scientists measure parasympathetic activity using something called respiratory sinus arrhythmia. This is basically just the concordance between your breathing and your heart rate. And RSA goes along with something called vagus nerve activation, which basically kicks your parasympathetic nervous system into gear. This system is related to emotion regulation, so lower RSA and lower vagal control have been linked to higher CU traits. Now, once all of this data was collected, we ran a statistical model. This was a multiple regression model that assesses whether one factor predicts another while taking into the account a bunch of different and overlapping impacts that each factor has on each other. So on the left, you see all of the indicators of sympathetic and parasympathetic activity, and on the right, you'll see CU traits, which was our outcome. So here, we saw, as indicated by the bold line, that during these tasks, only SCRs per minute during the PARC task significantly predicted CU traits. And what exactly does this all mean? Well, this shows us that context matters. We initially expected CU individuals to have lower fight or flight activity due to their baseline lower levels of fear. But an increased pattern of SCRs indicates that they had higher fight or flight activity, specifically during this PARC task. So let's think back to what the PARC task was about. You see a child hit another child with a stick, you see the mother loudly reprimanding her child, and then you see the mother hit her child. This was an aggressive family situation. So there may be something about the fact that it is such a situation that induces a higher level of stress in CU individuals, leading to this unexpected increased fear response. Well, what about RSA? We have to keep in mind that this was not done in a clinically marked CU sample, but rather individuals that had relatively higher CU traits. But this study does give us more insight into a theory about CU traits. One thing that differs between children with CU traits and children with conduct disorder is that family socialization and family affiliation is higher in CU traits and more of a marker. So these findings open up a road to investigate theories about the development of physiological reactivity over time and the development of CU traits. Thank you so much for listening, and I have questions, or if you have questions, I'd be happy to answer them. Yes.
I think it's really cool how you found a way to quantify something that has been seen in psychology and has been studied in a less numerical way in the past. How did you get involved in this project, and how did you like your experience working on it?
That's a good question. So for those of you who maybe didn't hear, the question was, how did I get involved in this project and what was my experience like working on it? So I've been interested in psychology for a long time. I think it's one of the coolest topics ever, and it's something that's relevant in everything that we do. And I really wanted to make it part of my undergraduate career. So I joined the BASE Lab, which is run by Dr. Nick Wagner, and I really was interested in things that interacted biology and psychology together. And this was basically how I got started with this project. I learned a lot about child development in that lab, and I'm super grateful to all of my advisors in that lab who opened up this topic to me and helped me learn more about it. Yes? Yeah.
Thank you so much. This was so interesting. I have a question about, I think it was called the tier test.
Mhm.
So I noticed the task of preparing a speech, it was a speech about the family in particular. So is that intentional, or is that supposed to have some kind of relationship to the incident of the mother hitting the child in the park? Is there any sense in which the participants are supposed to be thinking about family already by the time that happens?
That's a good question. So the Trier social stress test is basically designed to induce social stress. And what's interesting about the difference between the speech task and the park task is that in speech, when they're tasked with making a speech about what makes a family and why, the participant is given control over the narrative. So they kind of get to decide what makes a perfect family. And in the responses, we found that there was a lot of variation in whether people pointed to emotional aspects of family versus things like financial support. And in the park task, we controlled the narrative, and it was an aggressive family situation. So I think that the fact that we found marked different responses in that specific task is where that difference comes in. Otherwise, the whole task was meant to kind of point to affiliative scenarios and scenarios with like interpersonal interaction. So yes.
If there are no other questions, I have a question for you. What did you find to be the most interesting part of this project as the researcher?
Honestly, I think that callous unemotional traits is just a topic that I had never heard of until I joined this lab. A lot of times when people talk about psychopathy or psychopathic traits, we imagine something that is super harsh and like completely on a very like critical end of things, but it's important to view these traits as a spectrum, and the fact that these traits exist at all is something to note. And I think it's super interesting to think about what types of interventions might occur in early childhood and development that can prevent these traits from occurring and just form more productive and like beneficial social interactions in the future. Thank you so much.